Hello there, it's Alana. I'm here to help with 8.1 number 21 from the study plan. So let's click on the example. It says the reading speed of second grade students is approximately normal with a mean of 93 words per minute and a standard deviation of 10 words per minute. Complete parts A through F. All right, so part A, what is the probability a randomly selected student will read more than 98 words per minute? Now, the key in there is a randomly selected student, meaning it's only one student. So really, this is actually a review of a Chapter 7 problem. Now, you'll have to bear with me because I've actually already done this video twice, and my computer has eaten it twice. So hopefully this one will go through. All right, so I'm going to set up what my mean is and what my standard deviation is. And I'm going to do it in Excel here, and then I'm actually going to do it in StatCrunch. As you can see, I already did it in StatCrunch, but I'll show you again. So actually, I'm going to leave the picture up just so you can see what's going on. And even if you don't have a computer program necessarily to do this for you, it's a smart idea to kind of draw this on this picture for yourself so you can get a sense of it. So we have this picture here, and here's 98, and the mean is 93 in the middle. And then we want to know this area over here on the right. So the norm dist function finds the area on the left. So what I did was I found norm dist 98 comma my mean, which was 93, and I gave that dollar sign. So I said B1, cell B1, but give it dollar signs because I don't want the mean to ever change. It's always going to be 93. And then the standard deviation is B2, but that doesn't have dollar signs because that is going to change as the problem progresses. And we always say true for norm dist functions. The false one is not something we cover in this book. We're always doing true because we're always trying to accumulate this entire area, and that's what that is this cumulative or not? Which for us it always is in these normal functions. Not always in binomial, remember from chapter 6, because that was discrete. So sometimes you would want, individual bars, and that would be a false statement there. Or if you wanted to add them up, that would be true. And we always want to add up when we're dealing with the normal curve. So I find this, right, and that's the less than area, this white area over here. And then I take it away from 1, and I'll have the red area. And as you can see, I also found it in StatCrunch. Let me show you how. I gotta remember where I have StatCrunch, sorry. Okay, so let's see, open StatCrunch, and I go to, run it. Stat, calculators. There they are, calculators. I want the normal calculator right here. I say the mean is 93. I say the standard deviation is 10. And I want to give it the x value of 98. So I'm going to put that in, and then I'm going to pick my direction. And since I want to the right, I'm going to click to the right. And it's going to find this area over here. And see, look, it's 0.3085. And then I took a snapshot of it and saved it and copied and pasted it into Excel right here. Okay? All right, so then let's do it again. So let's double check ourselves first of all. 0.3085. Yep, 0.3085 is right there. Now the next one is, what is the probability that a random sample of 15 second graders are 98 words or more? Okay, so I'm going to put down here n is 15. And the first thing I'm going to have to do is find my new standard error. It's not standard deviation anymore. Standard deviation is for individual kids, individual students. Standard deviation, or standard error, excuse me, is the standard deviation of the x bars. How far apart are the sample means? So you take one random group of 15 students and another random group of 15 students and so on. And then you're going to have a standard error for that, and that's 2.58. Now I calculate that by taking B2, right, which was, I'm going to give it dollar signs because I never really want that to change. So it's B2, and then I'm going to divide it by the square root of B21, right? So B2, remember, was my standard deviation. It was 10. So I'm taking 10, I'm dividing it by the square root of 15. Enter. Okay, and then other than that, it's pretty much the same problem. You're going to find the area on the left, but using this now as your standard error instead of 10, you're going to use 2.58. Let me go do it in StatCrunch. As you can see, oh, and then I take it away from 1 to find the other one. So this is what I think the answer to part B is. So let me give it a big part B here. And then let me see if I can go back myself up with StatCrunch. Always useful to know. StatCrunch, honestly, is easier for a lot of these problems. So let's go to Stat, Calculators, Normal. Okay, 93 is the mean, but now it's 2.5, oh, what was it, 98? Let me go back. 2.582. Sorry, I was totally wrong there. 82. And then I still want 98, and I still want the greater than. And there we go, 0.026. So I'm going to click snapshot. I'm going to save this 8.2 number 11B. Export. Okay. And then actually I want to leave this up. Let me open up StatCrunch again. Let me see if this will work. I'm hoping that it'll let me see my data here and still leave this window open. Let's see. My results maybe? Ah, there it is, my results. Okay, so I click on that, copy, and it's taking its time, that's fine. And then I'll go back to Excel and I can click paste, and there it is, 0.026, just like I said. All right, so let me move all this stuff down. Again, sorry about this. I've done this problem twice. All right. So that was part B. Now let's look to C. So for part C, it's the same thing, but it's going to talk about 30 kids instead of 15. Right? It's the exact same problem. So what's the chances that 30 kids, 30 kids have an average that's 98 or higher? Okay, so instead of dealing with x's, we're dealing with x bars here, right? We're trying to get 15 kids to have an average of 98. Just think about this for a second. You could get a single kid to have a number over 98. That wasn't hard. That's like 31%, right? But having 15 kids have an average that's 98 or higher, that's hard to do because kids, scores, if they're random, will balance each other out, right? So you're going to have high and low, and they'll all be evened around 93 because 93 is the mean. So how do you get it to be so high? Well, your random group just happened to have a whole bunch of high scores is one possibility. Or maybe it wasn't really random to begin with, right? Maybe you had a biased sample. That's the kind of stuff we talk about in chapters 9 and 10 and 11. All right, so I'm going to do 30. And then again, I'm going to find my standard deviation. I want B2 divided by the square root of 30, which in my case is cell B42. So that gives me 1.8257 for my standard error. Even smaller because 30 is what you're looking at, right? So you're looking at groups of 30 that's going to have less spread than groups of 15, which has less spread than groups of 1, which is what we started with. This is the spread for groups of 15. This is the spread for groups of 1. All right, so again, I found the area on the left. I took it away from 1, and I got the area on the right. And then the area on the left I did by 98. And then the mean of B1, B43, that 1.8257 is my standard deviation now. True, right? And by the way, I didn't show it, but that's what it was here. 98, comma, B1, then B22, which is that standard error, comma, true, right? All right, so let's see if I can get Excel to match up with StatCrunch. So let me go, I can just pull up the Java cup here. So then I want 98, but I want to change the standard deviation to 1.8257. Compute. And you can see how teeny tiny it is, and it's 0.003 according to this. So I'll take a snapshot. 8.1, number 11C, this part is. Export. And it says it saved it, so let me go find my results. Let me go back to my StatCrunch, my results. There it is, 8.2, number 11C. I'm going to copy. Taking it a minute. And then I'm going to bring it back here and paste it in so we can see. And you can see how teeny tiny it is, right? Compared. 98 is so far from the mean when it's a group of 30. It's not too far from the mean when it's a group of an individual, right? Individuals, it's easy to get close to them or to be 98 or higher. And that's actually what part D is asking about. So I'll just kind of say that again, right? So I think part D is saying, what does this probability imply? Let me go look at it real quick. We're done with B, we're done with C. There it is. What effect did increasing the sample size have on the probability? Provide an explanation. Well, you hopefully can see it, but as your sample size got larger, which is this guy down here, right? 98 was further away from that mean. The reason being because your spread changed. If you lower your spread to 1.8, then being 1.8 away is being 1 standard deviation away. So we never really changed our numbers. Our mean was always 93 and our other number is always 98. Look, 98 right there, 98 right there, 98 right there. And the difference is that 98 is only a half a standard deviation away up here because it's 5 away, right? But 5 away down here is a little bit less than 2 standard deviations away. And 5 away down here is even further away, right? You see what's happening? It's that same distance of 5, but the larger group you have, the harder it is for that group to have an average that's that far away from the mean. If the mean truly is 93, then your groups of random 30 people should be close to 93. And it gets tougher and tougher the larger the group you take to be far away from that 93. Right? So our probability gets lower and lower because our spread is getting lower and lower, right? So this 5 away is easy to do up here, right? Because you have a large spread. So being 5 away means there's tons of area to the right. But down here you have a very tiny spread. So being 5 away is really far away down here, which means being to the right of that is really teeny tiny, that little red bit right there in the tail. In other words, as you increase sample size, you're lowering your spread, right? And that means that you're making it harder and harder to be out in the tail, because it's hard for a group of 30 to have an average that's far out in the tail, right? It's easy for a single kid to be out there. It's hard for a group of 30 to have an average that's out there, because that would mean that they're all way high. You have maybe one kid at 96 and that's it, right? And everybody else is high because that's how you're going to get an average that high. All right, so you'd pick whatever answer is appropriate for that explanation. All right, and then parts E and F. And we got to do this quick. All right, so part E says that you have a sample size of 19, and she found it to be, or he found it to be 95.8. So a teacher instituted a new program. After 10 weeks, it was found that the mean reading speed of a random sample of 19 grade students was 95.8. What might you conclude on this result? Is this rare or not? You know, is something happening? So yeah, I made the new standard sample size of 19. I found the new standard deviation, which is 10 divided by the square root of 19. And then I found less than 95.8 by using 95.8 in here, comma the mean, comma the standard deviation, that new one, which is 2.294, comma true. And then I took it away from 1. Let me go make a StatCrunch picture. Actually, I'm going to pause you and I'll make the picture. Well, maybe not. Here. If I just pull this up. Here, 93, and then we said it was, let me bring it back. 93, and we said this was 2.29, 2.294, and then we say this is 95.8. Compute. 0.1111, which is just what I found. I'll take a snapshot. 8.1, number 11E. Cool. All right, so then let me go back here. There it is. Copy. And I'm going to paste it right there. 0.1111, just like we said. That's not unusual because that's not lower than 5%. Remember, what's rare for us is lower than 5%. So if you come up with a number that's lower than 5%, cool. So then the last part was, well, what would make it 5%, right? What would have it be? There's a 5% chance the mean reading sample of 19 kids will exceed what value? So I'm giving you the area, 5%, and I'm asking you, what's the score? What's the cutoff score? Because 95.8 didn't do it. 95.8 gave us 11% out here in that red area. I want 5%. So that's a different question than all the other questions because I'm giving you the area this time. So the area on the right is going to be 5%, which means the area on the left, that white area, is 95%, which is 1 minus 0.05. Okay, so then you're going to have to use norm inverse. Norm.inverse, your area is 0.95, comma your mean, which in my case was in cell B1, comma your standard deviation, but that since it's 19 students, the standard deviation is the one we just found, which was 2.294 right there. And that's what I get, 96.77. And I can do it in StatCrunch real easily. Oops, I don't even need to go there. If I just pull up the little JavaScript, I say it's 93, I say it's 2.294, but I put in 0.05 right here and click compute. And there it is. To get a 0.05 area, I've got to get 96.77, which is exactly what it said I needed from Excel. So this is 8.1 number 11F.